Okay, this video is going to be on section 2.7 and we are going to be looking at the graphs of inequalities. And you can see from my table here that we've got four basic types of inequalities we're going to look at. We're going to look at an inequality where we are looking at numbers that are to the left of a given number, like right here, or to the right of a given number, or where I have a lower bound and an upward bound. And then also there's a type of inequality that's a compound inequality where I'm going to the left forever and then to the right forever, but leaving a space in between. Now this last type right here is not the type that we're going to be looking at in this course, but you are going to see it in college algebra. On problem number 1, I have the inequality x is less than or equal to 2. First of all, you need to be sure that you know how to read that inequality symbol. It is less than or equal to. Now I've got two different graphs over here, and it's because I'm going to show you two different ways to graph this. Now when you learn how to graph inequalities in high school, you probably looked at this inequality symbol right here and saw that there was a equal to sign under that inequality symbol. So you put a dot here on 2, and less than means you're wanting numbers smaller than 2, so then you would shade to the left. Now in this textbook, we're going to use a different notation for graphing. Instead of a solid dot here at 2, we're going to put a bracket at 2 and then shade to the left. Problem 2, I have the inequality x is greater than -3. And again, you need to be sure that you know how to read that sign. Now, greater than -3 means I can get as close to -3 as I want, but I can't touch it. In high school, you probably learned how to graph that by putting an open circle at -3 and then shading everything to the right. You know, putting an arrow there to be sure that it goes on forever. In this course, instead of an open circle, we use a parentheses. So a parentheses means that you can get as close to -3 as you want. You just can't actually touch it. Okay, I want to talk about this graph just a little bit more here. Again, my inequality says x is greater than -3. So why can I just not start my graph at -2? Well, the reason you can't do that is because then you would be missing out on all those fractions and decimals that are in between -3 and -2. That's why you have to indicate that open circle or a parentheses to show that you can get as close to this number as you want. You just can't actually touch it. Okay, problem 3, x is less than -1. The first thing I want to do is figure out which side of -1 am I going to shade on. Well, since I'm looking at numbers that are less than -1, I'm looking at shading to the left of -1. Now the next thing I need to do is figure out, am I using a parenthesis or am I using a bracket? And because I have a strictly less than, that means that I cannot actually equal -1, then I need a parenthesis. Okay, problem 4. Here you can see that my variable x is sandwiched in between -4 and +5. So I have a lower bound of -4 and an upward bound of +5. So I'm looking at this section of the graph. I just need to figure out what those endpoints look like. So at -4, I cannot actually equal -4, so I'm going to have a parentheses there. And 5 I can equal, so I'm going to have a bracket there. Okay, these next set of problems, my directions are to write the inequality that is represented on the number line. So here, I know that I've got an x and I've got a -5. I can write that down first and then figure out the rest of it. Well, first of all, I want numbers that are to the right of -5. So numbers to the right of -5 or bigger than -5 or greater than. So I know that my symbol is going to look like that. I just have to figure out, is there an equal sign under the symbol? And there's not. Okay. Remember that if you have an equal sign under the symbol of greater than or less than, you're going to have a bracket. If it is strictly greater than or strictly less than, you're going to have a parentheses. So problem 6, I know that 1 is the number that I'm interested in, and I'm looking at numbers that are smaller than 1 or less than 1. So that's less than, actually I'm looking at numbers that are less than or equal to 1. So I need to put that equal to sign under there. Okay, problem 7, I have a lower bound and an upward bound. So all of the values that I'm looking at for x are in between those two numbers. They are sandwiched in between -5 and +3. I just need to figure out, do either one of these symbols need an equal to sign under it? And I have to put an equal to sign under that first symbol because I have a bracket there at -5. Now, I want you to try to do problem 8 on your own, so pause the video, do that, and come back and check your answer. And there's your answer. And one thing I want to point out about this is that when you write a compound inequality like problem 7 and 8, the smaller number is always over here on the left-hand side, and the larger number is on the right-hand side. It's just how they would appear on your graph. Okay, this next set of problems, we are to graph each of the following. So problem 8 says I have a lower bound of -3 and an upward bound of +2. So I'm going to be graphing this part right here, and I just need to figure out what those endpoints look like. Are there going to be brackets or parentheses? Well, it's exactly like what is shown here in this interval notation. If I have a parentheses on that -3, then I'm going to put a parentheses on the -3 on my graph. Since I have a bracket at 2, I'm going to put a bracket over here on my graph at 2. The neat thing about using parentheses and brackets on interval notation is they exactly match the symbols on your graph. Now, problem 9 is a little bit different, though, because you have -infinity, which means I'm going out forever in this direction, right? Forever to the left. And as far right as I go is 3, and there is a parentheses at 3. So I'm going to shade all that middle part in. So any number that's in this shaded region is in between -infinity and 3. All right, problem 10, I want you to try to do that one on your own, so pause the video and come back and check your answer. And there's your answer for problem 10. Okay, problem 11 shows me that as far left as I'm going is -2, and I'm going to have a bracket at -2. And as far right as I'm going is +infinity. So I'm just going to draw an arrow to indicate that this goes on forever toward the right. Now problem 12 says I'm going from -infinity to +infinity. So that means I'm looking at the whole number line. Now I don't think you actually have any problems like this on your homework in this course, but it is something that you're going to need to know later on once you get into higher level math classes. Okay, the next set of problems, we're asked to write the interval notation that is represented on the number line. And again, this is easy to do because The symbol on my number line exactly matches the symbol in interval notation. If I have a parentheses on my graph at -5, then I'm going to have a parentheses on my interval notation at -5. Now I'm going all the way toward positive infinity, so write a positive infinity here, and I have a parentheses. And remember that infinity symbols always use parentheses. You never use a bracket symbol with infinity sign. And again, your interval notation is always going to go from your smaller number to your larger number. So in problem 14, my smaller number, or the number on the left I have, is actually negative infinity. So again, I have a parenthesis there for negative infinity. And as far right as I go is +1, and there's a bracket at +1. So let me give you a minute to try and do problems 15 and 16 on your own. Pause the video, write your answers, and come back and check them. And there's your answer for problems 15 and 16. Okay, for these next three problems, my directions say write the inequality that is represented by the interval notation. So problem 17, I'm going from -5 to infinity. It may help to make a quick graph of this first. I don't need to get too detailed here. Here's my -5 that I'm interested in, and I want to go toward positive infinity, so I want to go toward this side, and I need to have a bracket at -5. So the inequality here says that I want all numbers bigger than -5 or greater than -5. So x is going to be greater than or equal to -5. Problem 18, here's my quick sketch. There's 6, and I want numbers that are to the left, right, because I want numbers going out toward negative infinity. Have a parentheses there at 6. So I want numbers that are strictly less than 6. So I want all of the values that are less than 6. There's no equal sign under the inequality. Problem 19, I have my interval from -3 to 10. So there's a lower bound and an upper bound. So x is in between those two numbers. So I have -3 is less than or equal to x, which is less than or equal to 10. And on the last set of problems, my directions say to write the interval notation that is represented by the inequality. On problem 20, I have x in between -7 and 2. So there's a lower bound and an upper bound. So I have -7 as my lower bound here, and my upward bound is 2. There's going to be a parentheses at -7 and a bracket at 2. Problem 21, x is less than 8, so I want all of the numbers less than 8, and again, you may want to help get your answer by drawing a quick graph here. I want x to be less than 8, so those are the numbers toward the left, and there's going to be parentheses. So when I write my interval notation, I am going from negative infinity to +8, and there's going to be a parentheses on both sides. Problem 22, x is greater than or equal to -5. So a quick sketch shows me that I am looking at all the numbers that are bigger than -5 or equal to -5. So I'm going to have a bracket here. And again, when I do my interval notation, I'm looking at my graph from left to right. So from -5 to positive infinity.